Hi everyone. In last video, we already learned how to check if function is continuous or not. In this particular video, we are going to implement the concept of continuous function. Okay, so let me just revise it so that it will be better for us to implement those concepts into Python programming. We know that if we want to check that function is continuous or not, we need to check three things. Okay, so we need to first, like, I'm just writing the step over here so it will be easy for us to track it. So step number one, we have to find out the left hand limit at particular point. Okay, let's suppose he is asking uh, like if function is continuous at x equal to a or not. Okay, so first I will find out the left hand limit, and then I will find out the right hand limit. Okay, at x equal to a, and then I will find out the value of function at x equal to a. Okay, so if left hand limit, right hand limit, and the function all value are equivalent, then we can say that the given function is continuous. Okay, so we already discussed this thing. In this particular video, we are going to implement it into Python programming. Let's suppose we have a function f of x. Okay, so here if x is between 0 to 1, this will be the function, and if it is greater than 1, this will be the function. Okay, we need to check that if given function is continuous at x equal to 1 or not. So what will be the step? The very first step will be check the find out the left hand limit at x equal to 1, find out the right hand limit at x equal to 1, and then put the value exactly 1, and then check if all value are same, then we can say that the given function is continuous at particular point. Okay, so now let's start implementing this two thing first. Okay, so we can implement this thing by two way. Okay, so one thing is what? SumPy. Okay, so SumPy is a library by which we can already by which we can implement it. Other approach will be like last time, if you remember, we are implemented how limit work internally. Okay, if you know the concept Geno's paradox. Okay, what was the concept? I was explaining that if we want to find out the limit of a function from left hand side, so we will come closer and closer, and we will note down the value. Okay, just a minute if I can show you. Okay, I think this was a concept. Yeah, this was a concept. Just a minute. Okay, so we are trying to find out the left hand limit. So let me run this one. So we are finding limit from left, and we are finding limit from right, and then we are comparing it. So like this two step already we build in our last videos. Okay, so in this, like, we already done most of the part, but in this video I will try to implement not using like numpy. I will try to implement using sumpy. Okay, so now I think you are getting my point. Okay, why I'm going to implement using sumpy. So it will save your time. Okay, so if you want to use the previous code, you can go to the GitHub link where I have already posted this code, so you can use it directly. Okay, so now let's come to the point. Now let's implement it. So the very first step, let's import some library. Okay, so let me directly copy paste it, so it will save our time. So I'm just copy pasting. So here, okay, now the very first step is what? We have to define that. Let's suppose this is our function. Okay, yep. Because our function contain variable x. Okay, in our function, like here we can see this one. So we need to define what are the symbol we are going to use in our function. X equal to, we will use symbol, and we will say that we are going to use only x, and based on that uh, we will define our function. So if you're finding the left hand limit, okay, are you getting my point? So what will be the left hand limit? Okay, so that is a one tricky point. Okay, What do you mean by this thing? See here, let me explain this function first. So on number line, x equal to 0. So if something is sorry, x equal to 1. So if something is less or equal to, so if we are computing limit from left hand side, okay, if you are computing limit from the left hand side, what is going to happen? So this function will call, okay. And if you are computing limit from the right hand side, what is going to happen? We'll compute it. We will take this one. Are you getting my point? So basically, what you can do, see, let me compute it for you so that you will better appreciate it. Okay, just a minute. So let me define it. F equal to, so I'm defining f, let's suppose I'm saying f of L, and then here I'm saying that 5 into x minus 4. Okay, and then what I will do, I will say that at what point you are going to find out. So our point will be 0, sorry, 1. Okay, so at this point we are targeting to find out the limit. So there is limit function and SumPy. Okay, so we pass our function, what are the variable we are using, x, and what will be the point. Okay, now let's store the value at some, okay, so left result I'm storing here. Okay, and let's print it. Okay, so L result. Okay, so now okay, we missed something. Okay, I think we missed some variable. So the problem is here, like here was f of 1, so this would be f of L. So now if we print the left hand limit, so we are getting 1. Okay, so note down this result. Now same thing we will do from right hand side. So we are defining another function f of r, and then from right hand side the function will look like 4 into x cube minus 3 into x. Okay, and now we will store the right result equal to limit, and then we are passing this function. So variable will be same, and then point is also going to be same. Okay, so now if we, okay, just let me change this point also. So here I am just mentioning left hand limit. Okay, and then here let's print, let's write the print statement. Print right hand, okay, limit, and then let's print the result. Okay, so let's run it. So from left hand we are getting 1, and from right hand also we are getting 1. So like this step is already completed, step number 1 and step number 2. Now we need to put sorry, we need to put x equal to 1 in given function. So if x is exactly 1, so this will encounter, like this function will counter. So if like what we are trying to do, if I'm going to put x equal to 1 directly, so this this will be the domain for that one. So that means this function will call. Okay, so if we take it, okay, so let me define very simple. So uh, function at a, I'm saying it, so this will be 5, okay, into, so I'm putting 1 and then minus 4. Okay, so if you print the value, okay, if you print the value, you will see. So left hand limit, right hand limit, you are getting. So let me just rewrite it properly. See, f of 1 is also same. Now see, so at f of 1, okay, you are getting the same output. Okay, so if you compare this three equation, based on that, you can say that the given function, okay, this f of x within this domain is a continuous at x equal to 1. So the question was, we need to discuss that if function like f of x is continuous or not. So we can say that the given function is continuous at x equal to 1. Okay, so like you can modify this code also. This is just a straightforward code which I have written, but the code which I will push to the GitHub, I will just make it a proper function so that it will be easy for you to access it. Okay, so in this video, we are just ending with this thing. In upcoming videos, we are going to implement more function. Okay, so that means what, we are going to write more function to compute the continuity of the function. Thanks for the watching.